Welcome to the channel. Okay, let's jump right in. Today, we're looking at what I think is one of the most incredible paradoxes in modern municipal engineering, potassium permanganate. You know, it's a chemical that works absolute miracles to purify our drinking water. But here's the catch. If it's mishandled, we're talking severe corrosive burns and even spontaneous explosions. It's incredibly effective, but man, it demands absolute respect. Here's our operational briefing agenda for today. We'll kick things off with Section 1, its utility in water treatment. Then, Section 2, the hazards of KMnO₄. Section 3 covers essential PPE requirements. We'll move into Section 4, safe storage and handling, followed by Section 5, spill containment and response. And finally, Section 6, critical first aid procedures. Let's get to it.
Section 1, utility in water treatment. Let's talk about why we actually use this stuff.
We really need to understand the massive value this powerful purple crystal brings to water treatment plants across the globe. Now, historically, you might have heard it called Condy's crystals. Today, it's highly utilized as a primary oxidizing agent in both drinking and wastewater treatment. It acts as a broad-spectrum oxidizer. Basically, that means it rapidly cleaves the chemical bonds of impurities and toxic solvents, just completely converting them into harmless byproducts. It literally attacks physical, chemical, and biological impurities all in one highly efficient step. It's a real workhorse.
And when you compare it to the alternatives, it's easy to see why operators choose it. Whether you're looking at chlorine, ozone, or alum, potassium permanganate just gives you excellent multi-contaminant removal, especially for iron and manganese, all while maintaining really strong odor control. Plus, it's highly cost-effective, right? It's doing the heavy lifting of multiple treatment stages in just a single, simple dose.
So, how exactly is it operating in the water? Well, it oxidizes dissolved iron right into insoluble rust, it precipitates manganese, neutralizes that awful rotten egg smell from hydrogen sulfide, and it even controls biological growth like algae. But take a look at that risk at the bottom, the dreaded upset condition. Listen, if you accidentally overdose the system, you're literally going to turn your town's water pink or even purple. I mean, sure, it's technically safe from a toxicological standpoint at those low levels, but it will absolutely ruin people's laundry, and you are basically guaranteeing yourself a massive flood of angry phone calls.
Okay, moving to Section 2, the hazards of KMnO₄. Respect the danger. Now, I want to shift gears here and drastically slow down for a second. Because while it's super useful, the gravity of the hazards we are about to discuss just cannot be overstated. Potassium permanganate is a severe oxidizer. It's highly corrosive, and it is a toxic irritant. Direct exposure to the concentrated crystals or solutions can cause severe skin corrosion, devastating eye damage, and even acute respiratory failure if you inhale the chemical dust. You absolutely do not want this stuff on your skin or anywhere near your lungs.
To really wrap our heads around the danger, we have to look at what it means to be a strong oxidizer. By definition, this means it yields oxygen readily to stimulate the combustion of organic matter. And here is a terrifying fact. Simply mixing this chemical with something as common as glycerin or formaldehyde will cause a spontaneous fire. Literally just mixing them. Even combining it with finely divided combustible dust can trigger an explosion. Because it creates its own oxygen, it just accelerates burning to extreme, explosive levels.
Section 3, essential PPE requirements. Time to gear up.
If you're the operator handling this material, your personal safety is the absolute priority before you even think about cracking open a container. You need your safety goggles and a face shield. You need an MSA or NIOSH-approved dust mask. You've got to have impervious, chemical-resistant gloves, protective coveralls, and boots. And I really want to stress this. The dust mask and the face shield, completely non-negotiable. Inhaling this dust can cause immediate, severe airway swelling, and getting it in your eyes can cause permanent injury. So suit up. Every single time. No shortcuts.
Section 4, safe storage and handling. The critical do's and don'ts.
Let's look at how this builds into our daily operational protocols for safely storing and moving these free-flowing crystals. It really comes down to a stark contrast. Do store it in a cool, dry place. Do keep your containers tightly closed, and do only use clean, dry utensils. On the flip side, don't ever mix it with acids, fuels, or organic substances, period. And don't expose open containers to humidity. Keeping it isolated and dry gives it a perfectly stable shelf life. But if you accidentally mix it with combustibles or acids, you're risking violent, catastrophic explosions right inside your facility.
Section 5, spill containment and response. Emergency action.
But, you know, what happens when things actually go wrong?
Let's methodically cover how to handle unexpected leaks and spills. In an emergency, sticking to a calm, step-by-step cleanup process is exactly what prevents a bad situation from turning into a deadly fire. Step 1. Immediately isolate the spill area for at least 25 meters, that's about 75 feet, in all directions for solid spills. Step 2. Keep all combustibles, like wood, paper, or oil, far away. Step 3. For small, dry spills, use a clean shovel to place the material into a clean, dry container, covering it loosely. And Step 4. If it's a liquid spill, use a non-combustible material like vermiculite or sand to soak it up. Remember, never use combustible materials to clean up an oxidizer, ever.
Finally, Section 6, Critical First Aid Procedures. Immediate care.
If exposure does happen, extreme caution and rapid action are absolutely vital. A delayed response to a chemical burn or ingestion of this compound can easily be fatal. So here are the critical life-saving actions you need to memorize right now. If someone inhales the dust, move them to fresh air immediately. If it gets on the skin or in the eyes, flush the area continuously with massive amounts of water for at least 15 to 20 minutes to prevent deep tissue corrosion. Now, if it's swallowed, rinse the mouth out, but absolutely do not induce vomiting. Vomiting up a corrosive oxidizer will just double the damage to the throat and GI tract. And lastly, always call a poison center or EMS immediately to get professional medical help on the way.
So, I want to leave you with this provocative thought. Is your facility fully prepared and equipped for a potassium permanganate emergency right now? Do you have the right PPE, the proper storage isolation, and the correct emergency protocols locked in? Because knowledge and preparation are your absolute best defenses against the hazards of this incredible chemical. Thanks for hanging out with me today. Like and subscribe watching videos at Waterworks 101.